All right, so this is our circles portion. So what we're going to look at now is finding the area of a sector, or using the area of a sector, and then finding the length of an arc, or finding something using the length of the arc. So what we're going to look at here, the first one, is finding the sector area. Okay, the area of a sector AOB is 48 pi. Now what we're going to do is, I'm going to draw, because I'm just that kind of person that can draw, I'm going to draw me a circle. Okay, and it says that the area, so we're looking at area, all right, is 48 pi. Now the measure of angle AOB is 270. Find the radius of the circle. So what I'm going to do is, I'm going to draw an angle AO, and it tells me it's circle O, right? So O's in the center. So AOB right here is 270 degrees. Now what does that mean the arc is? It means the arc is also 270. But we're looking at the area of a sector is 48 pi. Now a sector is kind of like, it's actually me trying to get a lid on a marker. So the area of the sector AOB, okay, is 270. All right, sector AOB is 270. Now what we have here, that means that this right here is 48 pi. The 48 pi is the shaded area. This is probably not the best question, because you've got the measure of angle AOB. AOB's out of the center. So we should probably have another point over here and say that the area of this sector is so-and-so with another point. That's okay. So the area of that sector is 48 pi. Now we're talking about area, that's why it's shaded. I'm not talking about the circumference, we're talking about shaded. So find the radius. I want to know what the radius is. Okay, this is my center of my circle. So what I'm going to be doing is, I know that the sector area, which in this case is what? 48 pi. How do I get the area of the sector? Well, it's a fraction of the circle, right? So the fraction of the circle is the measure of the arc, and remember the arc is the same as the central angle, so my arc is 270 over 360. That gives me the fraction of the circle I'm looking at. I'm looking at 270 out of 360. If it were straight down the middle and it were a diameter, that would be 180. My fraction would be 180 out of 360, because now I'm looking at half the circle. So hopefully that makes sense. Times the formula for area, which is pi times radius squared. I'm looking for that fraction of the area. That fraction of the area gave me 48 pi. 48 pi is whatever this reduces to out of the original. So multiple ways you can go about doing this. So I'm going to take the 48 pi, and I'm going to take the 270 over 360, and I'm going to reduce that. So if you want to reduce fractions, you take it and you do the division, and you see what you get. Then you go back and you hit math, fraction, and that'll actually give you the fraction, so 3/4. So this is the same as writing 3/4, which is the same as 3 times pi r squared on top over 4. All I'm doing is changing the 270 over 360 to 3/4. Okay. So now what do I do from here? Well, it depends on how you approach it. So what we're going to look at is, first of all, I want to get rid of the 4. Now, do you remember how to get rid of a numerator or denominator? Well, I'm going to multiply by its reciprocal. So I'm going to multiply both sides by 4 over 1. Some people would put 48 pi over 1 and cross multiply. It's up to you. By doing that, those go away. 4 times 48 is 192. So I'm going to have 192 pi on this side. And then I'm left with 3 pi radius squared on this side. All I've done is multiply both sides by the denominator, the lowest common denominator, to get rid of the denominators. So my next step is going to be to solve for r? Well, I'm going to divide both sides by what's in front of the r, which is 3 pi. So that cancels, and that leaves me with r squared here. And then what's going to happen with the pi's? The pi's are going to go away. And then I'm going to do 192 divided by 3, which is 64. So now that I have my 64 equals r squared, I don't want r squared, I want r. So I'm going to square root both sides. So the radius is 8. So your radius is going to be 8. And it's 8 units, because we don't have centimeters or meters or anything. If you want to, you can write 8 units. Okay? So that's how we use sector area. Again, for sector area, you take the measured arc, which is 270, out of 360. You figure out what fraction that is. 270 is what fraction of 360, and we figured out 3/4. So basically, 48 pi is 3/4 of my area. So knowing that 48 pi is 3/4 of my area, I solved for the radius using algebra, our favorite thing in the world. Okay, so let's look at the second example. Let's look at the second example. So on the second example, we have circle O again. So I'm going to draw a different circle here. So I'm going to draw a circle right here. And O is in the center, okay? The length of arc AB, notice this is arc and this is sector, okay? The length of arc AB, we're not saying area like we did up here, we're saying length. So that's going to deal with, the length is going to deal with the circumference of AB is 2 pi. So what in the radius is 5. So find the measure of angle AOB. So I'm going to do A, and again, you don't know if your drawing is going to be accurate because you don't have anything really accurate. So I'm going to use AOB, and I know my radius is 5, and I know that the length, and notice we're talking about length now, we're talking about a piece of the circumference. Up here, the area, area of a sector is a piece of the area. It's a portion of the area. The length is a piece of the circumference. So now I know the radius is 5 and this is the length is 2 pi. So I want to find out what is the measure of this angle. Okay? I know the length of the arc in radians. That's what that is, the 2 pi. I know the radius is 5, but I don't know the angle. So I'm going to fill in, just like I did up here, everything I have and see what I don't have. Do I know the arc length? Yes, 2 pi. Do I know the measure of the arc or the angle? No, I don't. That is going to be your x. Okay, that's arc or central angle. Okay, and then I'm going to multiply that by 2 times pi times my radius. Do I know my radius? Yes, I do. Okay. So we're going to kind of be in the same situation we were on the previous one, where we're looking for what's missing. So if we're looking for what's missing here, we're looking for the angle. Now I don't have the angle, so let's look at what we have. I have 2 pi times radius. So the question is, what is that going to end up being? Well, when I end up multiplying this out, God, this marker does not want to close. That's my problem, not yours. So I have 2 pi equals x over 360. And what's 2 times pi times 5? That's 10 pi. Okay? And that's all over 360. So what I'm going to do now is I'm going to get rid of that 360. Again, you can put the 2 pi over 1 and cross multiply. I'm just going to multiply by the lowest common denominator. So I'm going to multiply both sides by 360 over 1, because what's going to happen? The 360s go away. So when I multiply 360 times 2 pi, I'm going to get 720 pi on the one side. And then on this side, I have x times 10 times pi. So I've got 10 pi x. And I'm back where I was before. So now I want to solve for x, which happens to be my angle. So I'm going to divide both sides by 10 pi. That cancels. The pi's go away. And 720 divided by 10 is 72. So that is your answer. Your arc and your angle are 72 degrees. Your arc and your angle are 72 degrees. So everything is, like I said, is contingent on what you have. And you have to plug in what you have to find what you don't have.